Okay, hey guys, this is some requests here from Ibby. So this is from the 2010 HSC paper. The first question we're looking at is question 17, which says, during a flood, 1.5 hectares of land was covered by water to a depth of 17 centimeters. How many kiloliters of water covered the land? Okay, so this is actually going to be a volume question. Okay, so we're told from a volume question that the area of the area of the land, I guess, is 1.5 hectares. Now we can't really deal with hectares. It tells us, and this is a bit of a hint in this question, that 1 hectare equals 10,000 square meters. So 1.5 times that amount gives me 15,000 meters squared. Now to find the volume of anything, we know the volume is equal to the area of the cross section times the height. We're also told that the height of the depth in this case is 17 centimeters. Now I can't compare centimeters with meters, so I'm going to write that as 0.17 meters, which is 17 centimeters. Now, in order to find my volume, we'll do 15,000 times it by 0.17, and that comes up with the answer of 2550. Now that is meters cubed. So how do I convert meters cubed to kiloliters? Well, actually, that there is 1 kiloliter in a cubic meter, because we know that 1 meter cube equals 1,000 liters, and 1,000 liters is equal to 1 kiloliter. Okay, and therefore the answer is 2550, which happens to be B. Okay, if you're not sure about the kiloliters, think about, I guess, meters to kilometers, okay, as in liters to kiloliters. We simply, if we're going that way, we times it by 1,000, okay, and that's why it's 1,000 liters, etc. 1,000 meters in a kilometer, so 1,000 liters in a kiloliter. Okay, next question. We're going on now to question 24b. This is 24b. This is a fairly straightforward one. It gives us two different graphs. It gives us a graph of c equals 40 plus 10x and the graph of y equals 20x. And it asks us to solve the two equations simultaneously for x. What that means is where the two graphs meet, or their point of intersection, what is the x value? Well, very clearly we can see that x is equal to 4. We simply have to read straight down and we can say that x is equal to 4. That's the first part in the first mark. And that says explain the significance of the solution for Ashley's business. Well, from that point onwards, you can see that the interest is greater than the cost, or should I say the income is greater than the cost. Therefore, I guess it's what we would call the break-even point, or maybe you can say that that's the point at which they start making profit. Okay, something like that gives a bit of explanation about why that point is significant. Okay, the next question now is going on to 26 A part 2. Joe's birthday is 30th of December 92, so she would like to have a number plate with either of these two options. Okay, so 30 Joe 12 or 19 Joe 92. Joe can order a number plate with Joe in the middle, but will have to randomly select numbers on either side. What is the probability that Joe issued with one of the number plates that she would like? Well, for this question, I like to do our place value. First of all, we want to find out how many possible combinations there are. Well, we know that the number plate has to have Joe in the middle, so there's only one option for J and one option for O, because we have to have those. The other options there, we have 10 numbers and each of the place values. So if we now multiply those together like we do to find any of our combinations, we should simply get 10,000. So there are 10,000 possible number plates with Joe in the middle of them. Now these are the two that she wants, so we actually have 2 in 10,000, which gives a probability of 1 in 5,000. Okay, because there are only 2 number plates that she actually does want out of 10,000 possible number plates with Joe in them. So 2 in 10,000 is the same as 1 in 5,000. Okay, let's move on now. Now this is looking at a bit of cumulative frequency. This is question 26C3. 26C3. I'm guessing this is the one that you're after. Use your graph to determine the median. Show by drawing lines in your graph and how you arrived at your answer. Well, hopefully you've already answered the previous question for this, part 2, which asked you to draw the ogive, which simply means to draw your line graph on top of it. Now remember, when you're drawing a cumulative frequency, we go from left to the right corners. Remember, cumulative frequency, it accumulates. Okay, so the 60 means that's your 100% of scores. Your 100% of scores. So that means that 30 would be your 50% of scores. Now, if we're looking for the median, we know that means the middle number, which is your 50% of scores. So if I go across here and get to the line, obviously yours is going to be a bit more accurate than mine, and come down here. Now, these are class centers. So I guess in a way, we could talk about this being continuous data, that it's not just the 162 group, that was a class center. So actually, your result down here, if we look at accurately from your graph, should be around about, I'm going to put that approximately equal to 155 or 156. If you do that accurately, again, that's measuring to see what that would be, making sure you look at the gaps between, okay, what it's going up by, and if you can even maybe draw the sort of little lines there to help you sort of gauge that. Okay, but that again is because you're using a class center, not just one set score. All right, let's move on now. We've got 2 more particular questions in this series. Okay, so use a graph to find the tax payable on a taxable income of $21,000. Okay, relatively straightforward question. Again, mine's not going to be dead accurate because I'm doing it on this. Okay, so this is where 21,000 is. So if we go up to see where that mark is right there, you can see that's going to be $3,000 because its tax payable is thousands of dollars, so it's simply $3,000. The next question, part 2. Okay, it says use suitable points from the graph to show that the gradient of the section for the graph marked A, which is this section here, okay, is 1/3. So in order to do that, you need to choose 2 particular points, or 2 suitable points that are on my particular graph. Now again, mine is not dead accurate. It's going to be hard to do it on here, but I've already chosen previously 2 points. So I chose the points 30 across and up 6. So 30 and then up 6. So that's that point there. It's a good idea when you choose your points to actually write down what the coordinates are. As you can see there, it's a little bit hard to see actually. I might use a different color. Okay, so again, that's 30 and then 6. And I also chose the 2 points 24 and 4, which is around about there. And now I'm doing my change in Y with change in X. You could, if you wanted, I guess, to draw your triangle that way or the other way and do rise over run. But I like to do y2 minus y1 over x2 minus x1, or the change in y over change in x, which would give me, let's say, 30 take away 20, 6 take away 4 is 2, and then 30 take away 24 is 6, which gives me 1/3, which is what the gradient is. That's what they asked for. Part 3 says how much of each dollar earned between 21,000 and 39,000, or A, that's what we just looked at, is payable in tax. Well, 1/3 is the gradient. That means 1/3 of the money spent, or 1/3 of my dollar, is tax. So 1/3 of a dollar is simply just 33 cents. Okay, so it means for every dollar I spend, I'm being taxed 33 cents. The very last question there then asked to write an equation that could be used to calculate the tax payable, again, between 21,000 and 39,000. So in other words, that A part. So we need to use our straight line equation of y equals mx plus b, y equals mx plus b. However, we know that m is 1/3. X plus b. You might want to put in the actual values, the letters that they've used. That's probably more appropriate. So in that case, t is equal to 1/3 I plus b. Now we don't know what the y-intercept would be, because remember, we're only taking portion of this graph, not the whole thing. So the y-intercept is not 0, okay? That's not that one there. So what we need to do is substitute a set of coordinates, and you can choose either of these two coordinates that I've used there. So I'm going to choose the 30 and 6. So I'm going to put 6 where the t is equal to 1/3 times 30 plus b. Okay, 6 is equal to 1/3 of 30 is 10, so 10 plus b. Therefore, b is equal to -4. But remember, this is in thousands, so I'm going to put that as thousands. So finally, my last step is going to be putting it back in. T is equal to 1/3 I -4 or minus 4,000, and that gets me my equation of my line of A, which is that line there. Okay, all right. Coming up now to the last question in the 2010 paper that young Ibby has asked for, or that you have asked for. Okay, so the last question here is question 28, and it was all of question 28. This is looking at some financial stuff. It's actually a lot easier than what it seems. The first question says, what is the change in monthly repayments on a $250,000 loan from February 2009 to April 2009? Well, if we look at $250,000, okay, we're looking at these amounts here, and we're looking from February to April, which is actually just those two amounts. So actually, it's nice and easy, because all we're doing is saying 1588 subtract 1573, which is equaling to a $15 decrease or increase, or whatever you want to call it, or difference. The second part, looking at Chang, who wants to borrow $307,000 to buy a home. Her bank approves the loan for customers if their loan payments are no more than 30% of their monthly salary, and we're told what her monthly salary is. So $6,500, let's times that by 0.3, which is 30%. We get a value of 1950. So if the repayments are less than 1950, then yep, she would be given the loan. If it's more than 1950, then she'd be refused. So we need to figure out what the repayments are going to be. Now this is a little bit more challenging, because if you have a look here, there's no $307,000. There's $300,000, and then there's other ones. So what we need to make up is the $300,000. We can't estimate here, and we're going to do 7 lots of $1,000. That might help us there. So for $300,000, sorry about squeaking in the background there. $300,000, we know we're making repayments there of $1,942. That's currently less than what we've got there. But remember, we've also need to find out what $1,000 is. We need to multiply that by 7, because it's $307,000. So the repayments for $1,000 is $6.47. Times that by 7, which comes to a total of $45.29. Now, if I add those two amounts together to find out what it is going to be for that $307,000, then we're going to have a total of $1,987.29, which is obviously more than what the $1950 that she has, which is 30% of the gross income. Therefore, she would not have been allowed to have that particular loan. Okay, that's the 2010 questions. I'll start work very shortly on the 2009 questions, but I am down at Snow, so it might be a little bit challenging to get them all done. But I'll give it a crack.